Hi there, welcome back to the formulaic approach. Now in this video we are going to be discussing the oil drop experiment. Now it is the late 19th century and J.J. Thomson had already discovered electron. So J.J. Thomson discovered electron in 1897, J.J. Thomson, and what was now remaining, or what was left to do about the electron, or what was yet to be known at that time, was the charge of an electron. So a certain scientist named Robert Andrews Millikan, R.A. Millikan, okay? Robert Andrews Millikan. So he and his team, okay, including a certain Fletcher, in the year 1908 to 1909, they began to experiment on how to calculate the charge of an electron. So they know that charges existed. So charges exist in nature, but their goal was to ascertain whether charges were discrete or charges were continuous. So it wasn't known then whether or not charges were discrete or whether charges were continuous. Now, what does this mean? Now, discrete charges means that charges exist in fundamental particles. They were quantized, okay? So they wanted to find out whether charges were quantized or they were just continuous. There was just any number that a charge could take. Now, let me explain that in more simplistic terms. Now, in our currency, for example, the lowest money, for example, that you can have is 1 naira. So I can gather as much 1 naira as I want. I can have 200 naira, okay? I can have 5 naira, okay? But I cannot have 5.2 naira, except we have something called the kobo, for example. So it is the kobo that breaks it down again. So which means that in the case where we have only whole numbers like this that can exist, then it means that our money is quantized. So our money can only be in multiples of 1 naira. Okay? But if it could exist as numbers in between like this, like 2.111 naira, 3.512 naira, those are continuous numbers. Okay, those are continuous because they are in between. They are not specific. They are not specific numbers. I hope you understand what I'm saying. So that was what they wanted to find out, whether charges were quantized, or in which case that means discrete, or they were continuous. Okay. Now, R.A. Millikan and his team set out to find out the truth about this concept by performing some practicals. Now, the name of their experiment was called oil drop experiment. Now, actually, before then, they had used water droplets to perform the same experiment, but water droplets evaporated quickly. Okay, so because of that, they needed to use oil droplets, which was more viscous and less volatile. They needed to use, so the reason why they used oil droplets was because water was less viscous and volatile, but oil was more viscous and less volatile, so it wouldn't disappear quickly. All right, now how did they go on with the practical? Now the apparatus or the setup that they used was something like this. It was like a chamber. Okay, I'm drawing the cross section. Okay, actually it's like a cylindrical chamber. All right, now it had the following components. So there is an inlet here where was the oil was connected, okay, the oil tube, and then a sprayer. Okay, there's a sprayer that could spray the oil into the chamber. So this whole thing here was called, the oil is here, and this is just a pressure pump that could cause it to be sprayed, cause the oil to get out of here and be sprayed in tiny fine droplets into the chamber. All right, this guy was called the atomizer, okay, because it's simplified or distribute or gave the oil in very fine droplets. Now, inside the same chamber was now an electric field, okay. Electric plates were set up. Now this plate is actually the cross section of the gave the um, was also flat and round, okay. It was also flat and round. I'm only showing you the cross section here. So flat and round with a small space here, with a tiny space in the middle. I guess that's not the middle. With a tiny space in the middle. Okay, so there is a space in the middle now. So it was such that when the oils were sprayed, when the tiny droplets of oil were sprayed, the droplets, okay, they're finer than this, but this is the smallest I can get, okay, from my marker. So this tiny droplet of oil would come on here and enter into this hole and fall into another section of the chamber here. So these are electric plates, and there's another one here. There's another electric plate here, very close to the end here. Now, these two plates were connected to an electric source. Okay, so they were connected to an electric source. So let me just put a battery here or any power source here. Okay, so it was connected to a battery source. Now that battery source actually has a dial. Okay, so this actually has a dial that can, that can be, you can, use it to control the voltage, to either increase or decrease the voltage. All right. So, and I'll tell you the use of that later as we go on. Now, there was also an X-ray. Okay. Let's just put it this way. So there was X-ray in the chamber, such that the X-ray could, ionize the air molecules here. Okay, it has ionizing effect, so it was able to ionize the gas in here, or even ionize the oil droplet that entered here. So they could do two things. The X-rays could do two things. They could either cause electron to attach to these oil droplets, or get an electron to be detached from them, electrons removed from them. So since these two plates are connected like this, the upper plate is going to be positive in this my setup, is going to be positive, and the lower plate is going to be negative. So the lower plate is going to be negative. All right, lower plate is negative. So it was such that this one was the ionizer. This is the ionizer, which will cause, so we'll call it ionizer or ionization chamber. So it would, ionize the air molecules here, so that there are electrons and there are electrons here, okay, that will get whether attached to the oil droplets, or the oil droplets gets to be ionized, wherein they lose electron, for example. Then there was where they could watch through a microscopic telescope, I think. It was just working as a microscope, okay? So keep in mind that was the period when the microscope was not as advanced as we have it now. So it was a very it was primitive type of microscope. The point is, there was just a microscope in here through which they could watch what was going on, okay? So they could watch. So think of this as the human eye, okay? So the human eye could watch through here. Here's the human eye. So here's my point now. You see? Now what they did was this. Before they turned on this guy, this voltage system, they would first spray the oil, and the oil is going to come in here. Okay. Now they will measure so that they'll be able to measure both the mass and the radius of this guy. Okay, of the oil droplets. So that during that time which the system was switched off, oil was under the influence of the following forces: the viscous drag, viscous drag, and the force of gravity. So gravity force or gravitational force. Okay, so with this they were able to calculate fundamental things about the oil itself. Do you understand now? So before I get into the mathematics of or the equation, okay, I want you to understand the way this system works. Okay, so this is what they did. They sprayed the fine droplets, come here, it enters into this place. Now they are going to now begin to regulate this dial such that the voltage, this is a high voltage source, keep that in mind, in thousands. Okay, it works with thousands of voltage, so they will regulate this. Now as they regulated it, first, why did they regulate it? Once this oil enters into this place, it's going to either gain an electron. So for example, if it gains an electron, in which case it's going to have a negative charge. So I've zoomed into an oil droplet that has gained a negative charge. If an oil droplet gained a negative charge, what will happen is that it is negatively charged because it has gained an electron from the ionized air. Now moving down, it's going to be repelled by the negative plate here. Make sense? So because of that, this voltage, so they were studying a droplet. Okay, they couldn't, so they would not study more than one droplet at once. Okay, and the droplet was of different sizes. Okay, so they will pick a droplet. They not pick. They will just focus on one droplet of the oil. So this droplet basically is a non-viscous machine oil. Okay, it's not granite oil or the non-viscous machine oil. So it comes down here, and so as it's coming down here, it's going to be repelled by this magnetic field. So what they want to do is, what that means is that being repelled by the magnetic field, the voltage will begin to be, regulated such that this thing can just float. Okay, because in this field there are two major forces that this oil is being influenced by. We have the electric force, and I'm going to show you how that is in mathematically speaking. The electric force and the gravitational force that is causing it to fall. Okay, gravitational force. All right. So as this oil is falling, they begin to regulate this thing such that the gravitational force and the electric force just equals each other. They equate each other. So, and during that time, at that particular voltage is the voltage at which that droplet of water, that droplet of oil is suspended in free air here. So it will be floating in mid-air here. So it is at that point. Okay, so they will measure that voltage at which this guy is in mid-air, and they already know the mass of this thing. Okay, so with that voltage, they are going to use series of equations that I will show you to be able to measure the charge on these particular droplets. Then they take another droplet, they will spray again and look for another droplet to study, and they did that experiment repeatedly for different sizes of oil. Okay, of oil droplets. They did it for different this and got a whole lot of recordings. And it was those recordings after calculation that helped them to find out that charges were actually quantized. Now, what does this mean? This means that there is a fundamental charge, which we call the charge of an electron. So this fundamental charge is the lowest amount of charge that we can have. We cannot have lower than that or a little higher than that. What we can do is have n number of that charge. Is that okay? So for example, if we have one electron, that will be the charge on that thing is 1 electron. If we have 3 electrons, the charge on that thing will be 3 times the charge of 1 electron. We cannot have in between that. So for example, they were able to calculate that the charge of an electron is minus 1.6 times 10 to the power minus 19 coulomb. Now, what they found out was that this charge is the fundamental charge, such that if something were to be charged, if there's an amount of charge on something, it is an integer multiple of this charge. I repeat that, if you say something is charged, that number of charge on that thing is an integer multiple of this. Okay, it is in number of this. So for example, a body cannot be 1.7 times 10 to the power minus 19 coulomb charged. No, a body can only be maybe 2 times this. For example, that would be 3.2 times 10 to the power minus 19, blah blah blah, like that. Do you understand? So a number of charge cannot exist in between what is not the, between what is the integer multiple of these guys. So I hope that is clear. I hope this is clear to us, the way this guy works. The sprayer, the atomizer sprays the oil, and he enters into this place, falls under the influence of gravity and electric force, and they measure the voltage and the mass of this guy, and they're able to tell the quantity of charge that it carries, given the voltage that is able to cause it to be suspended in free space there. Let me now show you how they did that mathematically speaking. Okay, now, so during the time that the oil is sprayed, okay, now when the oil is sprayed first, the oil is under the influence of, actually in the chamber, the oil is under the influence of 3 charges. The gravitation, there are 3 forces. The gravitational force, okay, it is also under the influence of the viscous drag, and it is also under the influence of electrical force. Now the gravitational force was useful for this. Now when the chamber is switched off and the oil is sprayed, okay, they are going to cause, when the chamber is off, the electric force is not acting on the oil. So when the oil gets sprayed and enters into that hole, that aperture, it is going to go straight down, and they are going to calculate the moment it attains what is called terminal velocity. Okay, so during that time, they know, therefore, when at terminal velocity, because the guy is freely falling, you understand what I mean by terminal velocity, right? For free falling objects. So as the oil is freely falling, it attains terminal velocity, and at terminal velocity, the force, the gravitational force, which I label F sub G here, is exactly equal to the viscous force. Okay, so it means that the gravitational force, which is mg, which is the weight of the ball of the oil itself, is going to be equal to 6 pi eta r v sub f. Okay, so the v sub f is the terminal velocity of the body, v sub t rather, terminal velocity, v sub t. So the terminal velocity of the oil, the coefficient of viscosity, okay, coefficient of viscosity of the oil, that's the eta here, and that's this way to write it, and pi, all of these are constants. Okay, so if this is calculated, this is known, the speed at which the oil gets to the ground. Okay, because the plate is separated by distance d, remember that the space is separated by distance d, so they know the height, the difference in the height of the space, the chamber, so they can already calculate the distance and the time it took the guy to get down. So with that, they will be able to calculate the terminal velocity, which will be distance d over time. Okay, now this distance here that I'm referring to is the distance between the plates. Okay, so what they probably will be calculating then will be when the oil just comes out of the aperture, then lands on the second plate that is below. Is that clear? So they use it to get the terminal velocity, and during that moment, they will be able to calculate. They already know the viscosity, the coefficient of viscosity of that oil. With the pi is constant. Then what's this called now? Gravitational acceleration, that's 10 meters per second squared, and then the mass of the oil. So they are able to calculate the radius of the oil, the diameter of the oil, okay, using this relationship, and of course, so that's primarily what this equation is for. Okay, so once they have gotten that, all those major things about the oil, then they can go on to turning on the electric source. Now once the electric source, the power source comes on, the oil is now subjected to two forces in between those plates, And the two forces are gravitational force and the electrical force. So the electrical force is given by F, which is equal to, remember that the electric field, the two plates create what is called an electric field, okay? And the electric field is equal to the force per unit of charge, the force per unit of charge on that oil. So it means that the force acting on that guy is going to be what? Electric field times the Q. So the electric field, remember, is given by the voltage divided by distance, the voltage on the plates, okay, which is measured from the positive plate now, the positive plate divided by the distance apart, their distance apart. So it means that our formula F becomes V Q over D. So with this, they know the electrical force that is acting on the oil. So they are able to now tell the so what they want to calculate is the charge, right? So since they want to calculate the charge, they will now equate the mass of that they have gotten times the mass of the oil times the acceleration due to gravity, because it is under the influence of. So they want to, inside that chamber, inside the between the two plates, the gravitational force will be equal to the electrical force. Okay, so gravitational force is going to be mg, mass of the oil, times the gravitational acceleration or acceleration due to gravity, times Fe, which is V Q over D. They know the distance between the plates, they know the mass of the earth, the acceleration due to gravity, they know the voltage that they have turned it on, and with that they are going to be able to calculate the charge on each droplet. Okay, the charge on each droplet by using the formula mgd divided by V. So with this, they are able to calculate the mass, the charge on each droplet, and they now found out that all the charges that they calculated was in the range was all the charges they calculated were integer multiples of 1.60. Let me clean here. Of 1.6022 times 10 to the power minus 19. Okay, so I'm going to simplify this to 160 zeptocoulomb of charge. Zeptocoulomb. All right, so they found out that an oil droplet either had 160 zeptocoulomb or 320 zeptocoulomb or plus that's 480 zeptocoulomb, like that, and you notice that is just one. This is 1 times 160, this is 2 times 160, this is 3 times 160. So they discovered that each of those packets of each of those oil had an amount of charge which was discrete, which was just integer multiples of these 60. So they discovered that, by so doing, they were able to discover that the charge of an electron is actually equal to minus 1.602 times 10 to the power minus 19 coulomb. And that was how the experiment went. So that will be it for this video. Do want to see my video on drift velocity and all of that, so that you can also understand the use of this thing. God bless you as you subscribe to the channel. See you next time. And share the video with your friend.